For the script, movies, or
Yeah, we're ready.
okay.
Let's do it.
In the room. Let's go up the numbers. Yeah, so I'm Spiros, and I'm going to talk to you about local first applications today. It's something that I tried a while ago, and I was really excited about this technology. Just a little bit of context so that you understand kind of like where I'm coming from. I used to be a developer for a couple of years, then I turned into a PM for 7 years, and then I realized that I maybe prefer doing development, so I went back to development last year. And now I'm working as a product engineer at makkuro.app, which is a search solution company. And last year, I had my entire 13 months free to work on my passion project, which is makkuro.app. It's a project management tool, and I spent 30,000 of my savings and a year building that. And I'm going to share some learnings about this, but specifically in the context of local first applications. So as I said, I was a PM up until 2 years ago, so I'm only going to scratch the surface of this new trend of local first applications. I'm not going to talk about the technical implementation of CRDTs or get into more technical details, but I will give you a lot of pointers and links and people to follow in order to get started if you decide to ever build an application this way. And of course, I will share some of my mistakes while I was working on this project, my project. So, as always, when trying to define a technology, there is a white paper. And this white paper was written about 20 years ago from a lot of smart people. You might recognize Adam Wiggins, this name. This is the CTO and co-founder of Heroku. And this is a common thing that is permeating across this technology. You will see a lot of people who build other things that kind of getting in here, trying to jumpstart this technology and increase the adoption. You will see Kyle Matthews from Gatsby, the person who created Gatsby. You will see Johannes Schicklin, who co-founded Prisma. So, yeah, you own your data in spite of the cloud. It's obviously a juxtaposition between the insecure, as the white paper says, cloud and your application locally and how you own your data and how interactions are very fast. The white paper describes certain principles, so you can read them. It's about no spinners and everything being secure and your fingertips. A diagram is always helpful, and traditionally you would have your front-end application, which will make requests to your backend server. The backend server is usually close to the database, gets the data, and then serves the data to your front-end. With this setup, actually, you have the local store, right? And you either build a system for that, or we're going to see some of the tools that are doing this work for you. You communicate with your local database. So it could be an IndexedDB from your browser. It could be an SQLite database. And then you do all the saves and writes and reads there. And this local data store is syncing with the backend on the cloud. What I'm keeping from this technology, what I'm excited about is the benefits in the user interaction. You have probably seen and used a lot of software, especially in the SaaS territory, where you have to wait, for even half a second, even 200 milliseconds might be a lot, and contribute to, a death by 1,000 cuts while you're using the old Jira, project tracker. And as always, there is a white paper from Jakob Nielsen about UX that talks about these different thresholds of interaction time. So below 100 millisecond, interactions are perceived as immediate. You don't understand that there is a delay. Beyond 1 second, you lose the user, and beyond 10 seconds, you've completely actually lost them. And most of these apps promise this. They give you this promise of 100 milliseconds, below 100 milliseconds latency, so that it feels like you're opening a file on your desktop, right? But you're actually accessing data that your user edited 5 seconds ago. Your colleague edited 5 seconds ago. And speaking of colleagues, this is another thing that comes for free with these setups. You get instant changes and syncs from other people, whether it is, you're saying different tabs in the same laptop, or if it's this other colleague at the other end of the world making a change. And also, you're gonna see a lot of this person, Thomas Hartman, who is the CTO and co-founder of Linear. He talks a lot about the sync engine that they built at Linear, and there are some benefits in the developer productivity from this setup. For example, because you're talking to the local store continuously, you don't have to do a lot of networking, REST API calls, and also because the latency that matters between your browser and the local store, you don't really care how far the backend or the database is. Like, especially for applications that you don't really rely on seeing the other person's feedback immediately, like when you're in Figma, you want to see the cursor immediately moving. But if it's something like a CMS, it doesn't really matter if the change happened 3 seconds ago. And 3 seconds is it's a crazy big latency number for other applications, but if you don't care about your application being slow and handling things very slowly in a queue, you can have a very cheap server and cheap database handling all these backend mutations, and you will just be talking fast with your local store. So one of the things that people tell me and ask me about this technology is that there are so many tools that have been new, and this is a new technology. How many companies have really used that in production and have scaled? And the first companies that come to mind are these three. Superhuman, this is this Gmail competitor, this very fast email client. They were famous for two things about 6-8 years ago when they went live. The first one was this great onboarding setup where they always pair you with an account manager and you have a personal video call of the person working with you through the platform. The second was this. They built some sort of a very fast, low latency syncing solution, and everything they did was free under 100 milliseconds. That was their UX threshold. And paired with keyboard shortcuts, you were able to fly through your emails, kind of like go to inbox 0 immediately and chain actions, sort of like a combo in a video game. So these were the first company that I noticed being very fast. Linear is obviously a very famous company for the quality they provide in their UI, the velocity, the faster performance that they have when you're editing content there. And these people spent, I think, 3 years, because I saw the first blog post in 2020 when they were talking about this linear sync engine that does all this work with syncing locally and remote. And then I saw another blog post 3 years later, so they're definitely building this for a while. They have the 1 to 3 persons people thing. So that's one thing also that I really like in this technology. You get the tools to do what Linear has spent building for 3 years for almost free, or the fraction of the cost. This is one of my favorite things with the tools that I'm going to show you indeed. And also Figma, if you use Figma, you know how fast it feels. Everything is collaborative, immediate. The co-founder of Figma talks about how they did the traditional operational transformation paradigm as they went for CRDPs in order to get the collaborative editing features working fast and smooth. The last one is obviously not a scalable, not even a famous product of this is the thing that I built last year. So Makkuro is a tool that I've been wanting to build for a decade almost. And since I got the time last year, I basically built it from scratch, and I wanted to get more acquainted with technologies that I have lost touch in the 7 years I was at PM. So I kind of went crazy with all the technologies. And Makkuro is a project management tool. It has your tasks, kind of like Linear. It has your feedback management, like product code, and it also has your help desk support with the messaging component. I noticed that a lot of small startups rely on these tools to get feedback from the customers and then turn this into work. So this was the tool that I built. And I'm going to try to walk you through the code base for it. I'll actually first go through the application. So for the Infinite. Okay. All right, so I think you get the gist, like from this UI, you can understand that this is kind of like an intercom kind of thing. So you take the conversations and you bind the conversations and you add nodes of feedback that you might have received from other sources. You can connect this feedback to tasks and projects, and then you manage the tasks. So I'm going to create a task now. I'm working online, so yes. I accidentally pressed the wrong button. I'm going to write another one. And this is created immediately, right? Let me open up the network tab. You can see what's happening. And I'm also going to open another tab. Push it to the limit. It's crazy. This laptop has like a RTX graphics card, and you see how slow it is. The state of modern applications. Crazy. All right, and we're going to look at the network tabs, which I can't find in this one. All right. So let's say that I want to post a comment, and I talked before about immediate sync. So whenever someone makes a change, or if I post a comment here, I'm going to see it to the right immediately. So what's happening under the hood is I'm going to post another one. Yeah, I guess I need to go there. So one tab is pushing imitation, right? And this tool that I'm using for local first is called replicas. What you're doing with what this tool does for you is that you define your limitations. So what I did here is I posted a comment. So limitation, I gave it a post comment name. There are arguments like the text, the connected tab, task, project, and so on. And then on the other end, which is the tab, or it could have been another browser of another user in another location in the world, it's pulling the change, and the payload response is the delta of the changes that happen. So it could be a put operation, it could be a delete operation. And how this works is that this is transaction that is listening to or actually I'm committing some transactions to the local store, and then this go into a queue. The local store save happens automatically, of course, in like 20 milliseconds. But then replicas, the sync engine takes care of pushing the queue to the backend, and then the backend listens to this queue and this other queue and these other different changes that happen, and it takes care, of course, of conflicts if there are any. And based on you might see, there's a client group ID. There's the push version, so these are some counters that you can understand where the changes stop and where you need to apply the other changes or when to pull for changes when you connect up to like 1 hour. So you can see the version of the server here, it's like 1462. And I'm pulling all the changes to the application. So this is kind of like how it works with all these tools in the network. And I'm going to do a very quick walkthrough of the code base. How much time do we have, Ari?
You have another 5-10 minutes.
5 or 10?
10.
7.5. Right. So do you
You have
remember
10.
this diagram that I showed you before? This is the tech stack that I'm using. I started with React.js in the front end, but transitioned to Solid.js because I just wanted to play with it. But also it turned out to be a very fast solution for a lot of data. I had like 1,000 tasks in one string with a lot of interactive elements on top, and it was rendering very fast. The backend doesn't really matter. I use Condor, but it could have been an Express application with a very thin layer of handling just the pull and push functionality. And I'm using Prisma to store my data to a simple Postgres database. So replicas is the thing that I'm using for doing all this syncing between the front end and the local data, which is an IndexedDB. In other cases, it could be an SQLite database. And also there is an optional socket.io polling mechanism because replicas doesn't listen to the server, but you tell it whenever there is a change. So let me walk you through what I just showed you in a little more detail. So if you work with Prisma, I think this is familiar. It's just my schema. It's a very typical database schema with models and everything. The difference is here. You get your last modified version, which is a number, a counter that increases with every change you make. And there's a deleted because replicas actually doesn't, it supports soft deletions only, which is a small annoying thing. And then there are the replicas specific models where the system keeps track of which browsers and which browser tabs get connected and what is the latest version. So that when the server is at the version of, let's say, 500, and my client is at the version of 445, I get the remaining 55 mutations from just basically where, let me show you. I'm just querying the database where I'm saying like where is last modified version greater from this version of the browser, and then I'm pushing just the changes to the client that just connected. Also, when I'm pushing changes, the mutation that I showed you before, it's a very thin layer of just transforming the mutations into changes via Prisma to the database. So this is the backend. In the front end, yeah, I'm doing this silly thing where you're adding context to the application. But in this provided, let's say to the task provider, which is where I'm getting the data for the task. What I'm doing with replicas is that I get this object from replicas and I'm subscribing to the changes. So whenever there is a change that's coming from the backend, and replicas listens to it and it writes it to the local store, to IndexedDB, this code is responsible for pulling this change, and then it sets it to a local context that I'm applying to my application. So there's a more performant way to do that, but yeah, I do that and it works because I load the entire thing, because you might want, for example, to get all the labels in the task, right? So whenever someone adds another, let me do that. In settings, I'm going to add another label. And without loading the other application, I need to see the new label. So test. So this should have shown up here. Yes, here it is. So that's why I'm listening to all the data changes and I'm subscribing to them via replicas. You've seen a lot of boilerplate code that I have to build, like this pull code and this push code with mutations and all that. But the thing that has been maybe that annoyed me the most in this setup was that replicas is a key value store. And if you've worked with basically any application, you know that most of them are relational. You have users that connect to tasks, tasks that connect to projects, projects that have comments, comments that have labels. And these are all relations. And with replicas and most of these syncing tools, they come with a key value store. So whenever you need to manage relations, I had to go and create manual mutations of handling the IDs. For example, when I'm moving, let me go to the mutations. So when I'm moving a task from a project to another project, I have to go and remove from the existing project, add it to the new project, and handle all the relations manually, which is not ideal. I'm not really proud or even confident that this code works 100%. So that's one of the things that I didn't like. Yeah, so I tried also other tools for a couple of weeks, but I'm not going to go into details now. So lots of these tools are new, and you have to be patient and maybe sometimes try out because many of them are beta. I work with Electric SQL, for example, which is a tool that promises that it does the thing with relational databases. So you just update the model and the relationships are updated automatically. But they were not ready, for example, like the mutation didn't work out of the box, so that was the problem. Some other challenges with local affairs in general is syncing large amounts whenever you have a large application. And let's say this application has like 1 gigabyte of data, and then someone signs up. What happens when they need to download everything to the local store? The first load will be, I don't know, like 1 hour of downloading data, so this is not ideal. Obviously, there are ways to do that by progressively syncing older and older data, but there's not, batteries included solution with that. Yeah, the relational updates I talked about. Incremental adoption is tricky. It's not like React or TypeScript where you can have both in the same system, but you basically have two huge systems talking to the same database. So either go all in from the start or you redesign an existing application. So if you want to get started, if what I presented to you makes sense, I found that a good fit for this kind of applications are mostly B2B SaaS apps with a lot of text-based content like CRMs, ARMs, productivity tools like Jira and so on. In general, when you have to make a lot of changes and go back and forth to the database, and these kind of B2B SaaS applications, they require the user to do a lot of interactions. So by saving these small milliseconds, you actually improve the quality of life for the users. A bad fit for this is most B2C applications where it's actually better to cache the data, and the first load really matters. So you can't wait for 3 seconds for someone to go and buy in your e-commerce site. You can't, of course, use this with media heavy site. You can't download like 5 gigabytes of video so that they're fast in your application. So if you're falling in the left column, there are some tools that you can get started. So with I use Verticas. It's great technology. It's also very cheap. It's free basically for companies below $200,000 revenue, and if they have like a lower amount of funding or not. But I will probably get started with either PowerSync or Electric SQL. So Electric SQL back in June was not really ready, but maybe they have improved since then. They handle a lot of the boilerplate code for you. They provide your sync engine that you can deploy, and then you talk to that instead of building things yourself. They provide relational updates, so you don't have to worry about managing relations with tasks and projects and comments and so on. And there's a special shout out to LiveStore, which is an early access tool, but it was created just recently from Johannes Sitting. Johannes is the co-founder and ex-co-founder and ex-CTO of Prisma, and he's one of the people in the industry that I really admire. He really has his finger on the pulse of new things, and he's been having this local first F.FM podcast also, where every episode is great. Like he talks to, there are 19 episodes, and every one of them is perfect, so you can watch that. So this LiveStore is his product, and if you want to try it out, you can just go and just make a donation in his GitHub repo of $5 and you can get access. There's also this local first web.dev. Maybe you can also visit that first and have a look at the people you can follow. A lot of other tools. There's like 50 tools that you can use. There's even the traditional CouchDB that we used to use in the past, Firebase, and some new ones, more experimental. So you can try out many different tools if you're experimenting for that. And yeah, I think that's it. How are we in time?
Very good.
Okay. Yes, do you have any questions about anything, about local first applications, about Makkuro?
How did you get into, what put you to go to the local first?
Slow B2B SaaS application. Every application, I think almost every application we use